In the previous video, we started with the molecular formula C3H8O, and we looked at one of the possible Lewis dot structures that you can draw that has that molecular formula. From this Lewis dot structure, we looked at other ways to represent the same molecule. However, we didn't have time to talk about bond line structures. So let's start this video by taking this Lewis dot structure and turning it into a bond line structure. If you look at the drawing on the left, it implies that these three carbons are in a perfectly straight line. But the drawing on the right does a little bit better job of showing what the molecule looks like in reality. Those carbons are not in a perfectly straight line. You can see there's a bend to them like that. So when you're drawing a bond line structure and you have a carbon chain, you want to show that carbon chain in a zigzag pattern. Next, let's think about the carbon-hydrogen bonds. If you were to draw every carbon-hydrogen bond in an organic chemistry class, it would take you forever. So we leave those out in bond line structures. Carbon is still bonded to these hydrogens, but we're going to ignore them for our bond line structure, just to simplify things. So I'm going to draw this around the carbon-hydrogen bonds, so we're going to ignore them for the time being. And now we have our three carbons drawn like that. And this carbon is bonded to an oxygen, and this oxygen is bonded to a hydrogen. I'll put in lone pairs of electrons on that oxygen. Next, we can simplify this even further. We can leave out those carbons. All right, so the carbons are still there. I'm just talking about not drawing these C's in here because it can get kind of confusing. So we take out those C's, and I'll leave off the lone pairs of electrons on the oxygen, and we have our bond line structure. So this is our bond line structure. It contains the same information as our Lewis dot structure does, but it's obviously much easier to draw. It takes less time, and it's going to help you out throughout your course when you're looking at chemical reactions. So let's focus in on some carbons here. So this carbon in red, right, that's this carbon. So the carbon's still there. We're just not drawing in the C. And let's look at our other carbons. So the carbon on the right is the one in magenta, so that's this carbon right here. And the carbon on the left is in blue, so that's this carbon. The carbon in blue is still bonded to three hydrogens, right? This carbon in blue is still bonded to three hydrogens. We just leave them off in our bond line structure. The carbon on the right is still bonded to three hydrogens, right? But again, we leave those off when we're drawing a bond line structure. And the carbon in the middle, this red carbon here, is bonded to an OH, right? That's already shown in our bond line structure, and it's bonded to one more hydrogen. So there still is a hydrogen bonded to that carbon, right? We just leave them off to make things easier to see. So let me go ahead and erase what I just did here, right? So let's take off those hydrogens. So those hydrogens are still there, right? We just know that they are there. So this just takes some practice. Right? This just takes some practice to figure out what these bond line structures mean. So let's do several examples of understanding bond line structures and the information that they contain. Let's start by analyzing this bond line structure, and we'll start with this carbon right here in magenta. So that carbon in magenta, I'll represent it over here, is bonded to another carbon. I'll use light blue for that. So that's this carbon right here. So there's a bond between those two carbons, and let me draw in that bond. Now we have another carbon. I'll use red right here. So the carbon in red is up here. I'll show the bond between those two carbons. And then let's use green for the next carbon. So we have a carbon right here in green. And finally, there's one more carbon to think about. So let's see, what color do we need to use here? Let's use dark blue. So we have one more carbon right here in dark blue, and I'll show that bond. So we have 5 carbons in this molecule, right? So 5 carbons. So let's write the molecular formula. So it'd be C5. Next, let's figure out how many hydrogens. Now, to do that, you need to remember that a neutral carbon atom forms 4 bonds. So let's see how many bonds we already have. We'll start with the carbon in magenta. The carbon in magenta already has 1 bond, and a neutral carbon atom forms 4 bonds. So if that carbon already has 1 bond, it needs 3 bonds to hydrogen. So 1 bond to hydrogen, 2 bonds to hydrogen, and 3 bonds to hydrogen. Next, let's go with this top carbon here, so the one in red. This carbon already has 1 bond. So it needs a total of 4, so it needs 3 more bonds, and those bonds are to hydrogen, right? So it's implied that those bonds are to hydrogen. Next, we'll go for the light blue carbon in here. So how many bonds does this carbon already have? Well, here's 1, here's 2, and here's 3. That carbon already has 3 bonds, so it only needs 1 more. So we can draw in 1 hydrogen. We know that carbon is bonded to only 1 hydrogen. Next, we'll do the green carbon. So the green carbon right here already has 2 bonds. Here's 1, and here's another 1. So if we think about a neutral carbon atom forming 4 bonds, that carbon needs 2 more bonds, and those bonds are 2 hydrogens. So we draw in those hydrogens there. And finally, the carbon in dark blue. The carbon in dark blue already has 1 bond, so it needs 3 more. So there's 1, there's 2, and there's 3. So now we've drawn out the complete Lewis dot structure for this bond line structure over here. And how many total hydrogens do we have? Well, if you count those up, you'll get 12. So the molecular formula is C5H12. Let's do another one. So let's look at this next bond line structure here, and let's focus in on our carbons. So we'll start with this carbon right here in magenta. So I'll draw that in right here. The carbon in magenta is bonded to 2 other carbons. So I'll make this top carbon here red. So there's a bond to the carbon in red, and there's a bond to this carbon here in light blue. So let's draw in those bonds. So we draw in those bonds here. And let's just keep going with our carbons. Let's assign our carbons first, and we'll come back to our hydrogens. So next, let's make this carbon right here in green. So we have another bond of a carbon to a carbon. And then let's go with dark blue. So we have dark blue over here for this carbon. So let's show that bond. And then we have another carbon over here. So that carbon is right here. And we can show our last bond. The carbon in red is bonded to a chlorine. So let me go ahead and show that. So there's our chlorine. And now let's think about hydrogens. And let's start with the carbon in red. Right? So this carbon in red, how many bonds does it already have? Well, 1, 2, and 3. It already has 3 bonds, so it needs 1 more. And so it's implied that that bond is to a hydrogen. So that carbon's bonded to 1 hydrogen. Next, let's do the carbon in magenta. So over here, how many bonds does that carbon in magenta already have? Well, here's 1, and here's 2. So it already has 2, so that carbon needs 2 more. So we can draw in a hydrogen here and a hydrogen here. It's the same situation for all of the carbons around our ring. If we go to this carbon here in light blue, it already has 2 bonds, so it needs 2 more bonds, and that must mean 2 bonds to hydrogen. So we could go around the entire ring and add in 2 hydrogens to all of these carbons. So let me make sure I use the correct colors here. So in blue, and then we have this one over here. So what's the total molecular formula for this compound? Well, we have a total of 6 carbons, right? 1, 2, 3, 4, 5, 6. So C6. And how many total hydrogens? We have 2 on 5 carbons, and then we have another one here. So 2 times 5 is 10, plus 1 is 11, so H11. And then we have a chlorine as well. So C6H11Cl would be the molecular formula for this compound. Let's look at 2 more examples, and we'll start with this carbon right here in magenta. So I'll draw in that carbon. That carbon in magenta is bonded to this carbon in blue, but notice there are 2 bonds between those 2 carbons. So the carbon in magenta is bonded to the carbon in blue, but there's a double bond between our carbons this time. And the carbon on the right here in red, there's a single bond between the carbon in blue and the carbon in red. So for the molecular formula, so far we know there are a total of 3 carbons in this compound. Next, we need to think about hydrogens. So we know a neutral carbon atom forms 4 bonds. So carbon forms 4 bonds. How many bonds does the carbon in magenta already have? Well, here's 1 bond and here's another bond. So the carbon in magenta needs 2 more bonds, and those bonds must be to hydrogens. So let me draw in those carbon-hydrogen bonds like that. Next, we think about the carbon in blue. How many bonds does the carbon in blue already have? Well, here's 1, here's 2, and here's 3. So the carbon in blue already has 3 bonds. It needs 1 more. So we show 1 carbon-hydrogen bond. And finally, the carbon in red already has 1 bond, so it needs 3 more. So we draw in 3 carbon-hydrogen bonds. So how many total hydrogens do we have? That would be 6 hydrogens. So the molecular formula is C3H6. You can start to think about hybridization states here too, because if you look at this carbon and this carbon, you know both of those carbons are sp2 hybridized. And if those carbons are sp2 hybridized, we're talking about trigonal planar geometry around those atoms. And we try to show that in our dot structure as best we can, right? Approximately 120 degree bond angles around here. So hybridization can come into it as well. Next, let's look at this one right here, which has a triple bond. And triple bonds often confuse students on bond line structures. So let's assign our carbons again. Let's start with this one right here in magenta. So let me draw on that carbon in magenta. The carbon in magenta is bonded to this carbon in blue, and there's a single bond between those 2 carbons. Next, there's a bond between the carbon in blue and this carbon right here in red. So that carbon in red, there's a single bond between those. The carbon in red is bonded to 1 more carbon than the opposite side of our triple bond. So that carbon in blue is right there. There's a triple bond between the carbon in red and the carbon in blue. So now we have our carbons drawn out. That's 4 carbons. So this would be C4 so far for the molecular formula. Next, we need to think about hydrogens. So the carbon in magenta already has 1 bond, so it needs 3 more bonds. So we draw in 3 bonds of carbon to hydrogen. The carbon in blue here already has 2 bonds. There's 1 and there's 2. So the carbon in blue needs 2 more. What about the carbon in red? Well, the carbon in red has 1 bond, 2, 3, and 4. The carbon in red already has 4 bonds. So the carbon in red doesn't have any hydrogens on it at all. And finally, the carbon in blue. The carbon in blue has 3 bonds, 1, 2, 3. So 3 bonds already, which means the carbon in blue needs 1 more bond, and that bond is to hydrogen. So now we have all of our hydrogens. That's a total of 6 hydrogens. So we can complete the molecular formula, C4H6. And once again, thinking about hybridization, this carbon and this carbon, right, they're both sp hybridized. And so we know the geometry is linear around those carbons. And so that's why we draw this as being a straight line on our bond line structures. It's because of the geometry. We're trying to reflect the structure of the molecule the best that we can. So practice your bond line structures because they're extremely important for everything that you will do in organic chemistry.